continue with trig equations. Suppose I want to solve 2 sine of x over 2 is equal to 1 over the interval 0 to 2 pi, and also for all solutions. Well, I know 0 is less than x is less than 2 pi. If I divide all of this through by 2, I see x over 2 is bounded between 0 and pi. So I can say 2 sine of x over 2 is equal to 1 is equal to x sine of x over 2 is equal to 1/2. Now, there are two numbers over the interval 0 to pi, where the sign values are 1/2, and that's pi over 6 and 5 pi over 6. So, x over 2 is pi over 6, or it's equal to 5 pi over 6. Solving these two equations, I get x is pi over 3, or it's 5 pi over 3. So my solution set is pi over 3 and 5 pi over 3. This is a sine curve that has a period of 4 pi. The x-intercepts were found in our first problem. You can find exact values on your calculator, depending on which calculator you have. You can actually do an intersection, or you can see it will give you your zeros right down here. So the solution set is pi over 3 plus 4n pi, because it has a period of 4 pi, or 5 pi over 3 plus 4n pi, where n is any integer. Now suppose I want to solve cosine of 2x is equal to x over the interval 0 to 2 pi. I can use the identity that cosine of 2x is 2 cosine squared x minus 1, and substitute it in, bring everything over to one side, and I see I can factor this. So I can use the zero property and say that 2 cosine of x is equal to 1, 2 cosine of x plus 1 equals 0, or cosine x minus 1 is equal to 0. Now this first one tells me that cosine of x is minus 1/2, which means that x is 2 pi over 3 or 4 pi over 3. While cosine of x is equal to 1 at x equals 0. So my solution set has 3 points, 0, 2 pi over 3, and 4 pi over 3, and you can verify this graphically. Suppose I want to solve 4 sine theta cos theta is equal to root 3 over 0 to 360. Well, I can factor a 2 out, and I see that this becomes a sine of 2 theta. So now I can solve this for sine of 2 theta is the square root of 3 over 2. And on the interval from 0 to 360, 2 theta goes between 0 and 720. So 2 theta has got to equal 60, 120, 420, or 480. So theta is 30, 60, 210, or 240. These are the values where sine of 2 theta is equal to root 3 over 2. So my solution set is 30, 60, 210, and 240. Now, if I wanted to solve for sine theta cos theta is equal to root 3 for all solutions, then I realize that all angles to theta are a solution of the equation by adding integer multiples of 360 to the basic solution of 210 or 120. So 2 theta is equal to 60 plus 360n, and 2 theta is equal to 120 plus 360n. Divide both sides through by 2, and I get a solution set of 30 plus 180n and 60 plus 180n, where n is any integer. Now, suppose I want to solve tangent of 3x plus secant of 3x is equal to 2 over the interval 0 to 2 pi. Now, one thing you can do is just make everything terms of secant. So tangent of 3x is 2 minus secant of 3x. And now we're going to square both sides. And when I square this and I multiply this side out, I get tan squared 3x is 4 minus 4 secant 3x plus secant squared. Now I'm going to replace the tangent squared with secant squared minus 1. And I see there's a reason we do this trick. Those cancel. And I can move my constant over. So I get 4 secant of 3x is equal to 5. Solving this for secant of 3x is 5/4. I want to convert this to cosine. It's easier for me to work with. So cosine of 3x is 4/5. Now, I want to multiply each term of this inequality by 3 to find the interval for 3x. So when I do that, I get the interval goes from 0 to 6 pi. Now you're going to need to use a calculator and realize that cosine is positive in quadrants 1 and 4. So you're going to get 3x is equal to 0.6435, 5.639, 6.926, 11.9, 13.2, and 18. Divide all of those through by 3. Get your solution set. Now we squared both sides, so we have to check that each solution is a solution to the original equation. And we find our solution set is narrowed down to 0.2145, 2.3089, and 4.4033. Now we know a piano string can vibrate at more than one frequency. It produces a complex wave that can be mathematically modeled by pure tones. So when a piano key with a frequency of F1 is played, the corresponding string vibrates not only at F1, but to F1, 3F1, etc. in F1. F1 is called the fundamental frequency, and the higher frequencies are harmonics or upper harmonics. And when we listen, we hear these as a very rich, complex tone. So suppose that the A key above middle C is played on the piano, and the fundamental frequency is 440 hertz. And the pressure wave is 0.002 sine 880 pi t. The string is also going to vibrate at 880, 1320, etc. The corresponding pressures are P2 is 0.02 divided by 2 times sine of 1760 pi t. P3 is 0.002 divided by 3 sine of 2640 pi t, etc. Now, if I were to graph these, you get this very sawtooth sort of look. What is the maximum value of P? Well, if you take a graphing calculator, it shows the maximum value of P is about 0.0317. We want the Y value, and you can do a maximum on your calculator. So the maximum occurs at about 0.000191, 0.00246, etc. You can read these off your calculator.